Hello students, welcome to my YouTube channel Dear Mathematics, and also welcome to the very important session, because in this session we are going to start the topic of integral calculus. Before this topic we have already discussed about the differential calculus, and in this topic we are going to start from the integral calculus, and it is divided into three types. So let us see what are the different subtopics in the integral calculus topic. The first one is integration, and the second one is area under plane curve, and the third topic is differential equation. I have already told that this is very important topic because this is the largest and biggest topic of the second year mathematics, and there are so many formulas in the topic of integral calculus. And before going to the topic of integration, let us see that again the integration topic is divided into two types, and the first one is so the topic integration, it is divided into two types. The first one is indefinite integration. Indefinite integration, and the second one is definite integration. So first of all, we are going to start integration, but specially we are going to start indefinite integration. After the completion of indefinite integration, we are going to start definite integration, and after the definite integration, we are going to start area under plane curve, and then differential equation, and we can conclude the topic of integration. But before going to the integral calculus, I have to tell that the differential calculus and the integral calculus are opposite of each other. So the formulas which we have already studied in the topic of differential calculus, and we have to get reversed, and then we have to go through the topic of integral calculus, and then we have to start from the indefinite integration. And in this topic we are going to start from the definition of integration. After the definition of integration, we are going to see the definition of indefinite integration, and then we are going to see the definition of definite integration. After the definite integration definition, we are going to see the basic concepts behind the integral calculus, and also the some of the fundamentals that are behind the integral calculus. And after the fundamentals of integration, then we are going to start, or we will see some of the important formulas that are available in the topic of integration. And then after the formula part, we are going to solve some of the problems that are based upon the topic integration. The first line you have to remember that the integration is the reverse process of differentiation. Integration is a process, differentiation is a process, and you have to make it clear that integration is the reverse or inverse or the opposite process of the differentiation. Let us move to the definition of primitive, or it is called as antiderivative, or also it is called as integral. So what is the definition? A function capital F of x, but you have to make the difference between the capital F of x and small f of x, because there are two functions. One is capital F of x and the second one is small f of x. A function's capital F of x is called a primitive or an antiderivative or an integral of a function small f of x if derivative of capital F of x is equal to small f of x. Let us take the capital F of x as the first function and the small f of x as the second function. So the derivative of first function is equal to second function. So by using this line, integration is the reverse process of differentiation, and this is the process of differentiation. And by using this process and reversing it, we can get the primitive or antiderivative or the integral. So let us reverse it, and we can find out capital F of x will be, as it is the derivative, and when it will be shifted towards the right hand side, then it will convert into the form of integral. So it is integration of, or integral of small f of x, and it will be integrated with respect to x. This is the operator. Here in the process of differentiation, the operator is d upon dx, but in the process of integration, it is the process of integration, this point dx, it is the operator. So if the derivative of a first function is equal to second function, then integral of a second function is equal to first function. And let me clear about that. Here small f of x is the derivative of capital F of x. So small f of x is the derivative of capital F of x. But when we are going to convert this situation and acquiring the reverse process, then capital F of x is the integral or primitive or antiderivative of small f of x. So capital F of x is the antiderivative, or you can say that it is primitive, or you can say that integral. You can take any one of the word out of the three words, is the antiderivative or primitive or integral of small f of x. So this is the process of integration and this is the process of derivative. But let me clear that there is some widened or some more information about the topic or the process of integration, and we will study later. But before that, let us make it clear that by taking an example, suppose derivative of sin x is equal to cos x. Then by using this line, again we are going to the same line or the same definition. Integration is the reverse process of differentiation. So by applying this we can have sin x will be equal to integral of cos x with respect to x. This is the operator and this is the integral side. Okay, so by reversing this condition of differentiation and obtaining the condition of integration, we are finding out the integral of cos x with respect to x, and this is equal to sin x. And let me clear by extending some of the fundamental words behind this definition, that is integral of f of x is with respect to x, and it is capital F of x. Here I have taken the same two examples, one from differentiation and another from integration, and both of them are based upon the fundamental, that is the integration process is the reverse process of differentiation. So the differentiation equation tells that the derivative of capital F of x, and that is equal to small f of x, and the another equation tells that the integral of small f of x, that is equal to capital F of x. So let us take some of the fundamental words that are behind upon the integration. So the function which is to be integrated is called the integrand, and you can see that this function is to be integrated. The small f of x function is to be integrated. So this is called as the integrand. So small f of x is called the integrand. Okay. Then let us move towards to the second fundamental, the function whose differential coefficient is the integrand. Okay, here is the integrand is small f of x. This is the integrand. So in the differentiation part, we are getting in the right hand side, this is integrand, and the differentiation of a capital F of x is small f of x. So this capital F of x is called as the integral, which is in the right hand side part of the process of integration. So this capital F of x is called as the integral. After the process of integration, whenever we are integrating the integrand, we are getting the integral. So capital F of x is called the integral. Again I am repeating it. Again I am repeating it. The function which is to be integrated is called as integrand. And after the process of integration of the integrand, we are with respect to the variable, and the variable is x here, and we are getting the capital F of x, and this is called as integral. So capital F of x is called as integral, and small f of x in the given equation, it is called as integrand. Okay, let us see the process of finding integral. This process, the process of finding the integral of a function of this function, that means integrand, is called as the process of integration. And here the variable is x, that means we are integrating. What is the work of dx here? we are just integrating the function with respect to x. So we are getting the we are taking the operator dx. So the use of dx is, this is an operator to find out the integration or the process of integration, and the work is that we have to integrate the integrand with respect to the variable x so that we can get the integral here. Then let us move towards to the types of integrations. Then let us come to the types of integration. As I have already told that integration is of two types. The first one is indefinite integration and the second one is definite integration. Then coming towards to the what is the indefinite integration, and in the later chapters when it will come in the case of definite integration we will see the definition of definite integration, but now it is the time for indefinite integration. So first of all start with the indefinite integration, but before going to indefinite integration let us come to see some fundamentals behind the indefinite integration so that it will be clear that what is the definition of indefinite integration. Okay, so as I have already taken that derivative of capital F of x is a small f of x. So by using the reverse process of derivative we can acquire the process of integration. So by reversing it we can have the integral of small f of x dx. It is capital F of x. Again let us put another function here, and that is differentiation of capital F of x plus any constant 2, and it will be again and it will be equal to small f of x, because as you have already known that derivative of capital F of x plus 2 by using the algebra of derivative of sum of two functions is equal to individual derivative of the two functions. So derivative of capital F of x plus derivative of 2, and you know that derivative of capital F of x it is small f of x. So let us put it, and then derivative of 2 as it is a constant, so its derivative is equal to 0. So you can put here 0. Then we are getting the value of a small f of x. So by using this fundamental we can have, and now we can put the reverse process of differentiation, that means the process of integration. By applying it we can have the integral of a small f of x with respect to x, and it is capital F of x plus 2, because we are just reversing the condition and we are applying or going through the phase of the integration. So in this first case you can see that the derivative of capital F of x it is small f of x. So the integral of a small f of x it is capital F of x. But in the second case a different function is there, capital F of x plus 2. So differentiation of capital F of x plus 2 it is again small f of x, and as we have proved here. Then by reversing the condition we have the integral of small f of x with respect to x, we can get the f of capital F of x plus 2. That means we are getting two different values of integral of f of x with respect to x. That means in the first case the same integral gives us the value f of x, capital F of x. But in the second case the same expression integral of small f of x dx gives us the value of capital F of x plus 2. That means we are now clear that the integral of a function is not unit. It may be different, or you can say that it has infinite number of solutions. So okay, so let us take some examples here so that it will be more clear to you. Suppose I have taken derivative of sin x, and you know that it is cos x. So by applying the fundamental of integration we can have integral of cos x with respect to x, and it is sin x. It is the first one. Then moving towards the derivative of another function, and it is sin x plus 1, and it gives us again cos x, because by using the algebra of derivative of sin x it is cos x, and then derivative of 1 it is 0. So no need to write down here 0, and just reversing the condition we can have integral of cos x with respect to x, and it is sin x plus 1. Again let us take another example, derivative of sin x plus 2. And here you can see that again the derivative is cos x, because in the function the trigonometric term, that is, or the trigonometric function, that is sin x, is added with a constant, not a variable. You can see that here is a constant, here is a constant, and in the previous example f of x was added with 2, that means it was also a constant because its derivative is equal to 0. So that by reversing this condition we can have the value of integral of cos x with respect to x, and it is sin x plus 2. That means it is very much clear that these functions contains a or added by a constant here. Okay, but in this case also, as for the previous cases, and you can see that the integral of cos x dx is not unique, that means it is different from each other, and it can have variety or infinite number of solutions or infinite number of integrals. Here you can find out sin x plus 1, sin x plus 2, so you can find out infinite number of solutions for the integration of cos x with respect to x. So this is called as indefinite integration, because you are not getting a finite or a fixed value or a fixed solution for this process of integration. You are getting or you are acquiring infinite number of solutions. As it is not definite, so it is called as indefinite. So due to this procedure, this integration process or the process of integration is called as indefinite integration, and this calculus is called as indefinite calculus. So we are reaching the conclusion that, or we are arriving in the conclusion for that, if, so this is the final answer, or you can save it in your memory. This is the finite or the final conclusion. This is the derivative of capital F of x. If derivative of capital F of x is equal to small f of x, then the process of integration tells us that whenever we are reversing this process of differentiation, we are getting integral of small f of x with respect to x, and it is equal to capital F of x plus c due to the indefinite integration. Due to the indefinite integration, this is called as integral sign, this is called as integrand, and we are integrating the function small f of x with respect to x, and this is the operator, and here we are getting the integral f of x, capital F of x, and c is the constant of integration. So you have to remember, this is the final conclusion or the final evidence of the integration chapter. If derivative of capital F of x is equal to small f of x, then integral of small f of x by reversing the condition, because this is the reverse process of differentiation. So applying this fundamental, we can have integral of small f of x with respect to x, it is capital F of x plus c. And by using this fundamental, now we are ready and we can go through the formulas of the integration. But by using the formulas of derivative, we can move towards to the formulas of integration. So let us see what are the formulas in the chapter of integration. So let us move towards to the integrals of some more important functions, but I have already told that we have to take the help of the differentiation process or the process of differentiation. So let us take the help of differentiation process and let us find out some of the important integral formulas. Okay, so the first one is derivative of x to the power n plus 1 divided by n plus 1, and it is x to the power n, but the condition is n is not equal to minus 1. First of all, we have to prove this case. Then we can go through the phase of, if this happens in the derivative case, then the integration says that, or the process of integration says that the integral of x to the power n with respect to x, and it is equal to x to the power n plus 1 divided by n plus 1 plus the constant of the integration. Don't forget to write down the constant of integration, otherwise it will hamper your mark in your examination. So If this happens in the process of differentiation, then by using the fundamental of process of integration, we can write down the integral of x to the power n with respect to x, and that is equal to x to the power n plus 1 divided by n plus 1 plus the constant. So let us prove this so that it will be clear to you. Derivative of x to the power n plus 1 divided by n plus 1. As n is a constant, so n plus 1 is must a constant. So taking or shifting this 1 upon n plus 1 towards the outside of the differentiation process, we can have 1 upon n plus 1 multiplied with the differentiation of x to the power n plus 1. But we know that the differentiation of x to the power n, and it is equal to n multiplied with x to the power n minus 1. By applying this fundamental here, we can have 1 upon n plus 1, then n plus 1 will be multiplied in the left hand side, n plus 1 into x to the power n plus 1 minus 1 by using this property. Then plus 1 minus 1 got cancelled here, and also n plus 1 from both numerator and denominator got cancelled here. So we have now x to the power n as our result, and x to the power n is the derivative of x to the power n plus 1 divided by n plus 1. So by the reverse process of differentiation, we can write down integral of x to the power n with respect to x. It is equal to x to the power n plus 1 divided by n plus 1 plus any constant c. So this is the first formula and very vital formula. All of the formulas of the topic integration are so much important for the examination. So this is the first formula of the topic integration. Then moving towards some of the notes and some of the sub formulas, you can say that based upon this formula. So the first note we can take it as, if derivative of x, because we know that derivative of x is equal to 1. So by applying, it is the, okay, you can also take it as the number 2 formula. Here we have to write down, it is the notes. Then it is the second formula. If the derivative of x is equal to 1 with respect to derivative of x with respect to x, it is 1. Then by reversing this condition, we can have integral of 1 with respect to x, it is x plus c. Or also you can write down it in a different manner, integral of simply x dx, integral of dx, it is x plus c. Then moving towards another formula, derivative of root x, and it is 1 upon 2 root x. It is 1 upon 2 root x. And let us shift this constant term, that means 1 upon 2, towards to the left hand side, as it is in the denominator part, and whenever it will be shifted toward the left hand side, it will be in the numerator part. So derivative of 2 root x, it is 1 upon root x. So by reversing this condition, we can have integral of 1 upon root x with respect to x, it is 2 root x plus c. 2 root x plus c. Okay, so these are the three formulas we have studied. Next, let us move towards to the some of the rest of the formulas in the topic of integration. And also here you can take this function or this third formula in a different manner. You can take it as x to the power minus 1 upon 2, because 1 upon root x, it is equal to 1 upon x to the power 1 by 2, and this x to the power 1 by 2 will be transferred to or shifted towards the numerator part, then it will become x to the power minus 1 by 2, and its integral with respect to x, it will be same 2 root x plus c. So you can also write down in the different manner. Okay, so next let us move towards to the next formulas of this topic. Then we know that differentiation of e to the power x with respect to x, it is e to the power x. So integral of e to the power x with respect to x, it is the e to the power x plus c. then derivative of a to the power x, it is a to the power x multiplied with ln a. But we have to shift this constant term towards the left hand side. So let us see what happens. Derivative of or differentiation of a to the power x divided by ln a with respect to x, it is a to the power x, and we have to convert this or reverse this condition into the form of integration. So a to the integration of a to the power x or integral of a to the power x with respect to x, and it is a to the power x divided by ln a plus any constant c. Then moving towards the sixth formula, differentiation of log x with base e, and it is 1 upon x. You know that the log x base e with base e, also otherwise called as ln x. Log x with base special with e, then it is also called as ln x. But whenever we are going to reverse this condition or this formula, we are obtaining integral of 1 upon x with respect to x, and it is ln modulus of x plus c. Why we have to go for the modulus sign? Because the function log x, its domain we are considering in the positive values only. Then let us move towards to the sum of the formulas of integration of the trigonometric functions. Okay, this is the sixth, then this is the seventh. Derivative of sin x, it is cos x. So the seventh formula of integration, it is integral of cos x dx. Cos x with respect to x, it is sin x plus c. Then the eighth formula is derivative of cos x. So this is the formula of integration. Derivative of cos x, it is minus sin x, but we cannot put the negative sign or any constant term in the right hand side. So let us shift this. Differentiation of minus cos x, it is sin x. So just reversing this, we can have the eighth formula of integration, integral of sin x with respect to x, and it is minus cos x plus c. Then moving towards the ninth formula, derivative of tan x, it is sec square x. So the ninth formula is integral of sec square x with respect to x, it is tan x plus c. The number 10th formula of differentiation, it is derivative of cot x, it is minus cos x square x, but I have already told that we cannot put a negative sign and also any constant term in the right hand side, so that our formula can be generated here. Differentiation of minus cot x with respect to x, it is cos x square x. So just reversing this, we can have the integral of cos x square x with respect to x, it is minus cot x plus c. Then let us move towards the rest formulas of the integration topics. Then this is the 11th formula, derivative of sec x, it is sec x into tan x. So reversing it, we can have integral of sec x multiplied with tan x with respect to x, it is sec x plus c. Then moving towards to the differentiation of cosec x, and it is minus cosec x into cot x, but we cannot put the negative sign here, so let us shift this. Differentiation of minus cosec x with respect to x, it is cosec x multiplied with cot x. So reversing it, we can have integral of cosec x multiplied with cot x and its integral with respect to x, it is minus cos x plus c. So these are the 6 formulas of the integration from the trigonometric topic, or that are based upon the trigonometric functions. Then let us move towards to the function of inverse trigonometric function. Okay. Number 13, derivative of sine inverse x, it is 1 upon 1 minus x square and its square root. Then the formula of integration, it tells that 1 upon 1 minus x square with respect and its integral with respect to x, it is sine inverse x plus c. The 14th formula is derivative of cos inverse x, and it is minus 1 upon 1 minus x square and its square root. Then the 14th formula of integration tells that. But before going to the 14th formula of integration, let us shift this negative sign here. Derivative of minus cos inverse x, it is 1 upon 1 minus x square and its square root. Then 14th formula of integration tells that integral of 1 upon 1 minus x square and its square root with respect to x, it is minus cos inverse x plus c. But you can see that this integral have two values. One is sin inverse x plus c and the second one is minus cos inverse x plus c. Then moving towards to the formula number 15. Differentiation of tan inverse x, it is 1 upon 1 plus x square. So the 15th formula of integration tells that 1 upon 1 plus x square, integral of 1 upon 1 plus x square and its integral with respect to x, it is tan inverse x plus c. The 16th formula is differentiation of cot inverse x, and it is minus 1 upon 1 plus x square. Then shifting this minus term or negative term here, differentiation of minus cot inverse x, and it is 1 upon 1 plus x square. So the 16th formula is integral of 1 upon 1 plus x square with respect to x, it is minus cot inverse x plus c. So these are the formulas, 4 formulas, and the rest of the 2 formulas, let us see them. Then moving towards to the 17th formula, differentiation of sec inverse x, and it is 1 upon x into multiplied with the square root of x square minus 1. So by reversing this condition, we are getting the 17th formula of integration, and this is 1 upon x into multiplied with square root of x square minus 1 and its integral with respect to x, and it is sec inverse x plus c. Then moving towards to the 18th formula, differentiation of cos inverse x, and it is 1 upon minus 1 upon x multiplied with square root of x square minus 1. Then just shifting this negative term towards the left hand side, we have differentiation of cos inverse x minus cos inverse x, and it is 1 upon x multiplied with square root of x square minus 1. Then by reversing this condition, we can have the 18th formula of the chapter integration, and that is integral of 1 upon x multiplied with a square root of x square minus 1 and its integral with respect to x, and it is minus cos inverse x plus c. So these are the 18 important basic formulas are there in the topic of integration. So in this topic, we have gone through the definition of integral calculus, then the definition of integration, and some of the basic concepts and some of the fundamentals behind the topic integration. And also we have seen, particularly we have gone through the topic of indefinite integration, and then we have gone through the formulas behind the, or formulas that are based or present in the topic of indefinite integration. In the next topic, we will move towards to the, or we will proceed through some of the basic algebraic properties of integration, and then we will solve some of the important problems that are based upon this formula, and also those are based upon those basic algebraic properties of integration. Till then, thank you.